Hello, to introduce myself, I am Ankit Asthana, a program manager in the Visual C++ team. One of my focus areas is to work on cross-platform mobile development experience for Visual Studio customers. Today, specifically, I'm going to talk about building cross-platform mobile libraries and binaries when targeting multiple platforms such as Windows and Android. I will demonstrate this through a couple of short demos illustrating this experience. Modern development today requires developers to provide their application for multiple platforms. One of the major investments in Visual Studio 2015 has been enabling cross-platform mobile development with C++. Developers using Visual Studio 2015 will now be able to generate dynamic static libraries and native activity applications when targeting the Android platform. This is in addition to all the goodies developers build for the Windows platform today. And the plan is to extend support for iOS as well in the near future. Visual Studio 2015 will provide the ability to share C code easily between these device platforms, along with a great cross-platform IntelliSense and a cross-platform debugging experience. So let me show you how this experience looks like through a couple of short demos. As a part of the File New Project menu, developers will now see the cross-platform node light up under Visual C++. With this node selected, developers can see a variety of templates made available to them. The first template selected here is the Dynamic Shared Library template. This template would allow developers to build a dynamic shared library for the Android platform. This library will contain all the C code for the application and can then be used to create an end-to-end application using technologies like Xamarin or Java. The next template that I want to talk about here is the Native Activity Application template. Android with API level 9 allowed technology to create an end-to-end C++ application. This is fairly popular with game engines like Unreal and other graphic-intensive OpenGL applications. Let's take an example of this application template type. So here I have the OpenGL solution. This is a native activity solution. This has two projects, the native activity project and the packaging project. Let's take a look at the native activity project by looking at the project properties. As you can see, by taking a look at the configuration type project property, we're currently building a dynamic shared library and we're targeting Android API level 19. Also notice that as a part of our enablement, we're using the Clang toolchain made available from the Android Native Development Kit. Let's now explore the other packaging project. The packaging project is basically used to create an APK file from the SO file provided by the Native Activity project. For doing so, we basically call and use the Ant build system. Next, let's explore some of the source in the Native Activity project to demonstrate some of the other features. For doing so, I'm going to bring up the main.cpp source file, and I'm going to traverse to the Android_main function. The Android_main function is the entry point function for any native activity application type. To demonstrate the debugging experience, I'm going to set a breakpoint on this source line. Now, if you take a look at my debug target window, it's already lighting up with the VS emulator for Android entry. Microsoft, as a part of its cross-platform offering, will also provide a robust and fast x86 emulator. Since I already have the emulator running right here, I'm just going to hit F5 and try to debug my application. On doing so, the application builds and is deployed to the emulator. As you can see, the breakpoint that I set was hit, and all the other debugger features like the locals window and the call stack all light up correctly as well. Next, I'm going to hit continue and run the app run on the emulator. This will allow me to demo a few features on the emulator. This is a basic OpenGL app and it responds to user touch by changing screen colors. I can use emulator features like screen rotation and some other features such as the accelerometer and the other GPS services provided as a part of its sensors. To conclude, using this experience, developers can easily create a native activity application for the Android platform. As I mentioned at the start of the demo, our offering will allow developers to easily share their cross-platform mobile code between multiple platforms. For doing so, we've added support for a Mercury-style project to the Android platform as well. So let's take a look at an example. So here I have the cross-platform lib solution. This solution has 3 projects. The first project currently selected here is the cross-platform lib Android project. This project contains all the Android-specific code and is currently building a dynamic shared library. Likewise, the Windows cross-platform lib project contains all the Windows-specific source and is currently building a DLL. The shared project component is used to share cross-platform code between these 2 platforms. Next, I'm going to bring up the cross-platform lib.cpp source file to demonstrate the cross-platform IntelliSense experience. As you can see, this source file is colored with multicolored squiggles. This is due to the fact that this source file currently has code specific for the Android and the Windows platform. The purple squiggles appearing here is essentially the Windows IntelliSense lighting up. In this particular case, it's because the Android log.h header file is specific for the Android platform. Likewise, the red squiggles appearing here is the Android IntelliSense lighting up, as __m128 intrinsics is an extension provided by Microsoft and is specific for the Windows platform. To conclude, using this solution, developers can easily share the cross-platform code and also use cross-platform IntelliSense to easily convert their platform-dependent code into platform-independent. To summarize what was demonstrated in the demo videos, here are a few feature capabilities C++ cross-platform mobile developers can benefit from when using Visual Studio 2015. To highlight, developers will now be able to develop cross-platform mobile binaries, and while doing so, they will be able to share their cross-platform code easily and benefit from a great cross-platform code authoring and debugging experience. Thanks for watching this video. For more information about cross-platform mobile development with C++, please see visualstudio.com or follow our team blog on VC Blog.